Hello and welcome to another video. In today's video we have another AIME problem this time. It's from the most recent AIME 2024. This is the AIME II, not the AIME I, and problem 4. You can go ahead and give this problem a try if you haven't already. I'll be going on to the solution now. Okay, so I have rewritten the equations that we are given as well as what we are trying to find. And I'll go ahead and read the original problem that was on the AIME II. It says, let x, y, and z be positive real numbers that satisfy this system of equations. Then the value of log base 2 of this expression here is m over n. So it's going to be some fraction. Where m and n are relatively prime positive integers, find m plus n. So that's another way of just saying you want to find the answer, and which is going to be a fraction, and just sum the numerator and denominator when it's in lowest terms. So before we even start, it's best to set some variables. As you can see, we're going to be working with log base 2 of x, log base 2 of y, log base 2 of z. I'm going to have log base 2 of x be equal to a. I'm just setting a variable to these. Log base 2 of y is equal to b. Log base 2 of z is equal to c. The reason why I'm setting these variables is later on you'll see that we're going to be writing log base 2 of something, x, y, or z, many times. And it can get kind of hard to evaluate visually if you have written log base 2 so many times. Setting variables makes it easier to write and also visually easier to analyze. And so let's go ahead and expand that first equation out. This should just be a minus b minus c. Why is that? Well, if you know your properties of logarithms, when you subtract two logarithms of the same base, you can divide what is inside that argument. So a minus b minus c, I'm just going to write that out. What would that look like? That's log base 2 of x minus log base 2 of y minus log base 2 of z. Using properties of logarithms, that gives you this right here. This equals to 1/2. This is just what is given. And let's go ahead and do the same for the next two equations. As you can see now, it's a lot easier that we used variables, because if we didn't set variables a, b, and c, we would have to write log base 2 of x, y, and z over and over again and be hard to look at. But this is so much cleaner and simpler. Okay, now we can see that we have 3 equations and 3 variables, so we should be able to solve for each one. Let's add the first 2 equations that we have. If we do that, we'll get a minus b plus b minus 2c equals to 1/2 plus 1/3, which is essentially 5/6. As we can see, the a's cancel and the b's cancel, so we have negative 2c equals to 5/6. Solving for c, we will get c equals to negative 5/12. And we can do a similar thing for another 2 equations. Why don't we add these equations now, just like we did with the first 2 earlier? Adding these 2 equations, we will get b minus b minus 2a minus c plus c equals to 1/3 plus 1/4, which is just 7/12. Again, b's cancel, c's cancel. We're going to have negative 2a equals to 7/12, or a equals to negative 7/24. Now we just have to solve for b, in which you can add the first and the third equation, or even faster, you can just plug in a and c into any one of these 3 equations and solve for b. And if you do that, you should get b equals to negative 9/24. So now we have a, b, and c. But what was the question asking for again? It wanted log base 2, or the absolute value of log base 2 of x to the 4th, y to the 3rd, and z squared. Kind of like what we did earlier, let's expand out this logarithm. If we know our properties, this over here is just equivalent to log base 2 of x to the 4th plus log base 2 of y to the 3rd plus log base 2 of z squared, and of course the absolute value. Cannot forget that. Another property of logarithms is that when you have an exponent like this, you can just move it to the front. So let's do that. And I'm not going to write log base 2 of x because we have a variable for that. Log base 2 of x is a. So I'll go ahead and skip a step and just say 4a plus 3b plus 2c, and the absolute value of that. So now all we have to do is plug in a, b, and c, and you should get on the inside negative 25 over 8, but the absolute value of that is 25 over 8. This is not our answer though, because on the AIME we cannot have fractional answers, which is why they ask for m plus n, which is the numerator, plus the denominator. So on the AIME you would put 33 with a 0 in front. Thank you so much for watching. Please like, share, and subscribe.